Hi, everyone, and welcome to the Sargassum Podcast. Today, I'm co-hosting with Evelyn and Jenna, and I want to ask, how are you guys doing, and what's been going on in your lives?
So I've been pretty good. School has been busy for me with finals coming up, so mostly just been focused on that.
What about you, Jenna?
Well, I've seen Robbie, but I haven't seen you yet to let you know. I did get into a PhD program, so I'll be starting in the fall of 2023 at UC Santa Cruz, and I'm really excited.
That is really exciting. I did see that on Facebook, and I got really excited for you because I know how long you've been waiting for this as well.
My third cycle applying.
Wow.
Good luck on that, Jenna. Well, I've been well, Fran. I am actually helping you to do this new Sargassum Champions course.
Yes.
That's the new thing I am doing right now. And well, I am very happy to join this guest. I am excited to hear about their projects.
Yeah, me too. And actually, I'm currently in Atlanta, which is very close to our guests. I could have actually gone and seen them in person, and maybe this week I'm doing that too because I'm at Ocean Visions conference for the week. So that starts tomorrow, and it's my first in-person conference since COVID. So that's very exciting. So our two guests today, Joseph Montoya and Harshini Vummadi. Joseph Montoya is a professor at the School of Biological Science and director of the Interdisciplinary Ph.D. program in Ocean Science and Engineering at Georgia Tech. And Harshini is a third-year biology major, also at Georgia Tech, who focuses on sargassum and oceanographic studies. Welcome to the podcast, Harshini and Joe.
Hello, delighted to be here.
Yes, thanks for having us.
Well, we are happy to have you both here. And we want to start with a question that we always do to our guests. What is sargassum for you both?
I can answer that first. So I think for me, I grew up in South Florida, so I kind of saw sargassum, but I never really thought much of it until I got to college and started actually researching it. So I think to me, sargassum is an interesting biological problem because obviously we all know about the problems it's been causing in the Caribbean and in South Florida and Texas. And so I would like to learn more about the properties of sargassum and the ways that it can be used in some way that can benefit everyone.
For my part, I'm a biological oceanographer. I've been interested in and have worked in open ocean ecosystems for many years. I've known about sargassum for years, had seen it for years, but beginning in 2018, we began seeing enormous quantities of sargassum during research cruises in the tropical Atlantic. Became interested in it, and my lab group has been working on trying to understand what is promoting the growth of sargassum and why it's growing now in this tremendous abundance. So to me, sargassum is an interesting macroalga. It is an organism that supports a diverse community of other organisms. In the open ocean, it provides physical structure where you otherwise don't have any physical structure. Lots of organisms live in and on sargassum. So in some ways, it's like a moving coral reef or tropical rainforest, a little diversity hotspot out in the open ocean. Very different situation when it washes up on beaches. Again, my group is trying to understand why it's growing and where it's growing, partly with an eye to understanding its impacts on the open ocean, but also with an eye to being able to understand how it will affect island nations and coastal communities both in the US and the Caribbean and in Mexico.
And can you explain to us how you are exploring sargassum and its uses in purifying water?
Yeah, I can talk about that. So essentially, we first started exploring the uses of sargassum as a bioremediate after looking into the high levels of arsenic found in sargassum. We found that sargassum is just very good at uptaking arsenic and other heavy metals, and therefore we wanted to see, okay, if it can uptake these heavy metals, what else can it do? And can we use this thing that first seemed like a detriment into a benefit? So I currently am focusing on looking at how well sargassum is able to uptake toxic dyes and uptake potentially caffeine, as caffeine is one of those pollutants that the Caribbean has a lot of and is also something that's toxic to many aquatic systems. So therefore, through looking at both of these pollutants, we can see exactly how sargassum is able to uptake these and measuring the rates of uptake and percentages of uptake.
Harshini, we also know that you did a discovery trip to the Dominican Republic last year. What is the current situation with sargassum in the Dominican Republic?
Right. So I did a 10-day trip to the Dominican Republic over the summer where we went to both the capital, Santo Domingo, and then where the resorts mainly are in Punta Cana. And so while sargassum isn't an issue in the capital, we definitely saw a large abundance of it in Punta Cana, where we were able to visit several resorts to see how they each individually tackle sargassum. We saw resorts that had people manually collecting it off the beaches in the mornings and at night. We saw them build these barriers like 500 feet out into the ocean to try and catch it, and then use boats to pick up the sargassum that builds up on these barriers. And we spoke to a lot of different people who all had their own personal research projects or strategies, all in like an attempt to solve this problem. And so I think I was able to, I guess, like learn a lot about how like the problem is in a whole affecting the tourism industry. And it definitely feels like the major players in the tourism industry are certainly concerned. And the government is also starting to recently get concerned. We spoke to a government agency while we were in the DR, and they were able to tell us about how they believe that sargassum is negatively impacting their coastal environment and why they believe it's a problem. We also got to hear the economic side from the tourism industry and how they believe it's been driving customers away as it, it ruins their beaches and makes it so that many people don't want to return. And so overall, I think the situation there right now is one where people are slowly starting to come together and realize that this is a problem that needs to be tackled soon.
Yeah, so that seems like a situation seen in a lot of Caribbean places. And I really like your solution to use the sargassum and the negative part that is always put, that it's hard to make products because it has arsenic and heavy metals in it, and just flip it around and say, if you can take up all of that, then let's use that. So how does that, like, purifying water solution, how will that look like in the future when it goes on to these islands? Like, can you actually, is it going to be easy to use that locally in the Dominican Republic and in the Caribbean? How easy is it to make the product that purifies the water? Like, what does it look like?
Right. So I think the level of processing that we are planning on doing for our sargassum for our testing it will be just drying it and then grinding it up into a particulate. So pretty minimal processing. And my hope is that it can be used locally by, say, resorts that have their own wastewater treatment systems. And then it can also be scaled up to, say, a more national level in which the government may want to use it as like a low cost alternative to removing these pollutants from their waters.
I wanted to ask something else about the trip to Dominican Republic. Can I ask you, did you ask them which year have been, or what year have been the most aggressive with the beaching of sargassum in the Dominican Republic?
Yes. So one of the individuals we spoke with, I believe, said that the growth to them has seemed almost exponential, that each year it seems to be so much more than the preceding years. And so the way we've seen it is that like the sargassum growth has just grown more and more, and therefore the most pressing years is always the most recent. I've definitely seen stuff even in the news talking about how there's like a 5,000-mile patch of sargassum that's like in the Atlantic right now. So I do believe it's been growing year by year.
Well, it is like that. Now I would like to ask something to Joseph. Your research is rather interdisciplinary with biologists and engineers. They have to work together. What do you think are the benefits of working together? And do you think there are times that maybe it's difficult, or how did you deal with this?
So at least the kind of work I do is just inherently interdisciplinary. We can't go out to sea without involving people that are interested in physics, chemistry, and biology. And most of us have to work across those traditional boundaries just to do our own work. Bringing engineers into the mix really brings in a different culture, and it provides interesting contrasts and approaches. And what I mean by that is that engineers are fundamentally in the business of making things, designing things, trying to solve tangible problems. Scientists are in the business of trying to understand how the world works. These are complementary but very, very different approaches to dealing with the natural world. So, I think it's absolutely critical to engage not just a broad array of scientists and engineers, but both communities together. And if we want to address any sort of problem that people are dealing with, as an example, the work we're doing on sargassum in my group really has focused on understanding what the nutrient sources are, what the growth conditions are that really support sargassum. We've gotten involved with colleagues in trying to design ways to perhaps harvest sargassum out at sea before it gets onto beaches. That becomes an engineering problem. And I don't know if that was my beep or one on someone else's. I'm going to back up just so that we don't have that beep if it was mine. My group has become involved with efforts to try to harvest sargassum before it actually approaches beaches. This is a fundamental engineering question as well as a scientific question, and it's given us the opportunity to work with marine engineers, marine architects, and electrical engineers, among others, in trying to design systems and at least conceptually come up with approaches for harvesting sargassum and sinking it so that it never approaches a beach, never becomes an economic problem.
Can I ask something else
Yes.
about that? Yes. Joseph, when you talk about seeking sargassum, what do you think about that as all your experience you have in this field?
So, to start with, a lot of sargassum sinks naturally. I've been in submersibles in the Gulf of Mexico, and we've seen sargassum that looks pretty intact on the seafloor in 1,000 meters water. It's unclear how much is naturally sinking in the Atlantic. We suspect that a lot is, but in terms of efforts to actually harvest and sink sargassum, that would be I think, very efficient way to potentially move carbon dioxide from the atmosphere into the deep sea rapidly and with really minimal environmental impact. And what I mean by that is that sargassum is sinking naturally anyways, and these efforts would not involve any kind of artificial cultivation or growth of sargassum, rather harvesting it and sinking it quickly and efficiently. The goal would be to get sargassum to at least 1,000 meters depth. If you do that, then the carbon that's in the sargassum, even though it's going to be consumed and respired by deep sea organisms, will take what to humans is a very long time to get back up to the sea surface and into the atmosphere. So in terms of what I think about it, I'm hopeful that this will be an effective strategy for at least partly ameliorating the injections of CO2 we've been making, while also potentially helping to protect some of these island and shoreline communities from these influxes of sargassum. And I think it's technically very feasible.
Yeah, I definitely agree. I mean, that's kind of my day job to figure this out for the company I'm working on, and that's what I'm also presenting at the conference. So I'm very much in agreement with Joseph on this. And I love how this whole episode is about cleaning up. It's about cleaning up the sargassum. It's about cleaning up the wastewater. And it's about cleaning up the CO2 in the atmosphere. I think that's really awesome. Do we have any more questions?
No, I really like how he described the sargassum, because he says something that I have never heard about it. A moving reef
Yeah, I have to
Yes.
I
in
have
the
to
ocean.
confess that's not original. I've heard other people describe sargassum as either floating rainforests or upside down floating reefs. But, I'm always happy to steal others' great framing.
Yes, I did hear the rainforest, but I've never heard the reef one either.
Mm-hmm.
And
Same.
as a coral reef biologist, I would say it may be a bit wrong because the reef is supposed to be like rock, but the reef is something that's close to the surface or can even be above the surface. So in some ways, it really does make sense to call it a floating reef.
So I was thinking mostly in terms of the physical structure and the way that organisms are exploiting it.
Mm-hmm.
You're absolutely right. It's not
Yeah.
calcified in any way. If we have time, I would suggest asking Harshini about this science-engineering interaction because she's been enmeshed in that in this DR project.
Yes, we definitely have time for that.
Yeah, I'd be happy to answer that.
So Harshini, how is it to work between biologists and engineers and scientists from different disciplines?
So I would definitely echo Dr. Montoya's sentiment in that engineers are very much problem solvers. So a lot of the time when we approach this problem, they immediately start coming at it from the direction of solutions. Oh, what can we do? Instead of taking a step back and looking at, oh, what are the properties of sargassum? Like, what do we know about it? And then thinking about how it might be used. And so I definitely feel that that is like the perspective I offer to our group, which is mostly engineers. And then they can take the insights that I'm able to give them and turn around and try and find solutions based on that information.
Yes, that definitely sounds familiar to me. Like I work with engineers and I really like it because they're problem solvers and they make us really cool tools to go with our scientific instruments, and they are really good at solving engineering problems. But at the same time, it's good to have me there too, who knows about the sargassum and can say, no, that will not work, or that maybe this works, or this is needed for the sargassum. Yeah, because it is an interesting algae that is a bit fussy at times as well. Harshini, how long do you think your research will take? Like, how long does it take to develop um, like from the beginning to the end product for this water purifying solution?
So I've like just begun my project. I'm still working on my methods section. And so right now my samples, I've mostly just been processing them the same way we process most of the stuff in our lab, which is dissecting the sargassum, oven drying it, grinding it, and then we pelletize it to send it to the mass spec. But I'm going to be grinding extra so that I have some to run in my bioremediation experiments. But the process itself of taking, I guess, like wet sargassum straight from the ocean and turning it into a product that can be used in like a bioremediation process should really only be a few days. And most of that would be drying time, depending on whether someone is sun drying it or if they have a faster method. I believe sun drying should really take no more than like 2 to 3 days. And then you can just process it through some sort of like industrial grinder, and that would be some method to like mass produce ground sargassum. And so again, I believe that entire process would only really take 3 days. My research is a bit more delicate given that we're separating the sargassum out by growth zones, and therefore the dissecting always takes quite a bit. And then hand processing every sample means that this project should take me several months to probably
and I mean, you also want to find out which type of pollutants can the sargassum take out. So you need to have the control and the pollutants, and then afterwards actually analyze the samples. So that it just does take time. But it's really good to hear that it's in the end, the end product will be such an easy process. And from my experience, if you dry it in the sun, if it doesn't rain, it's dry within like a day. Like you only need the whole day. And I know if you dry it in a hall, it takes 2 days, like 48 hours to dry. That's what colleagues told me. So it's not that difficult.
And there is also like when you want to do some experiments or to analyze what kind of elements the sargassum has, do you have problems like, because I knew that maybe for some techniques you don't need the sargassum to be over dry, like 60 degrees Celsius. They need to have like 40 degrees Celsius, being drying in 40 degrees Celsius, no more than that. Do you have like a temperature that is needed for your special bioremediation experiment?
I don't have a specific temperature yet. That might be something I would want to control for and then use as like a variable to see if temperature might affect the ability of it to like uptake like different chemicals. But I think in general our standard is to keep the oven around 60 degrees Celsius. I mean, Dr. Montoya can comment on that as well.
Yeah, we try everything at 60. Drives off the water, and for our analyses, that's convenient. For the metal or dye or caffeine absorption, no idea. We've never looked into that until Harshini took that on.
Yeah, I don't have any more questions. I think all my questions got answered.
Yes, well, thank you both for giving your time.
It's nice,
Thank you.
nice meeting all of you. Nice chatting. Francisca, if you do wish to come over to campus, let us know. And
Yes, I will. I will let you know. I'll talk to my colleagues today or tomorrow. My other colleagues coming tomorrow. And I think we should come visit on Thursday afternoon if you guys have time.
I should be in
Okay.
the lab around Thursday afternoon, so
Okay.
Thursday
Perfect.
would be a good time, I think.
sounds good.
Okay, so yeah, hopefully I see you guys later this week.
Sounds good.
And thank you so much for being on the podcast. I think this was really, really interesting.
Yeah. Good meeting you all.
Yes, thank you very much.
Yeah.
Yes, it was
Thanks
nice
for
to meet
having us.
everyone.
So what do you guys think? What did you learn?
I love the attitude both of them had with just how interdisciplinary oceanography and marine science need to be, really, in order to understand and come up with solutions for any kind of problems that they're working with. I love that merger.
Yeah, I agree. Like we made those disciplines to make silos to make it easier to understand, but that's not how nature works. There's no silos in nature. Like it's all interconnected.
Right.
And if as soon as you want to come up with solutions, you don't only need the scientists but also the engineers. Otherwise it doesn't work.
Yes. Yes, and I remember that I am an engineer surrounded by biologists. So I understood what they said, and when Hashini told how engineers think, the first thing I thought actually when I saw these beaching events in Cancun is how can I solve? I never asked myself what is this. I so oh my god, it's so natural for an engineer to think first, okay, I need to solve this first, and then I will go to the background or to the morphological thing of the species and to know what is this really happening. So, but what I have learned of working with biologists is that you have to have both thoughts, like this problem solving, but also this basic science to figure out how does the organism is working, and then to figure out like a special solutions designed for that kind of a species or a scenario, I would say. But I really like the way they describe also the sargassum, and I am happy to know that we are part of this increasing community of thinkers that knows more of sargassum.
Yeah, I agree that like when engineers and scientists work together, like the engineers can come up with really good solutions, and the scientists can help to make really rigorous tests of these solutions, like make sure that there's a good control and that we are testing for a lot of different things that maybe the engineers don't think about, while the engineers think about all the really cool things how to actually make the solution that the scientists may not know or think about or have a different brain for. So it's very exciting to be working with those type of people, and exciting to see that it happens in a lot of places. And I also love the water purification idea, and that it is used for something as common as caffeine, which everybody, there's so many people who drink coffee or caffeinated drinks, so it's probably in the wastewater of every hotel, of every municipality. And if we really can make something as easy as just drying and grinding the sargassum and then using it to put the water through, that would be a really good solution, I think, and easy to implement all over the Caribbean.
Yes, I forgot to ask about that. What will be the next step after the sargassum has absorbed everything?
Oh yeah, where to put the sargassum?
Yes, I forgot to ask
Yes.
that. Yes, I think it's a question I will try to her.
Yeah, maybe she doesn't know the answer either.
Yeah, I was going to say that might be in
Well-
the next, the sort of next steps that hasn't been reached yet. But
Oh, if you see her this week, you can ask her
Yes,
for me,
I will.
please.
and it was exciting that no one at her university had looked into that at all. This is like a brand new thing that they're doing that she came up with, or her team came up with, which is really neat.
That is really neat. So I think we're getting to the end of our episode. It was really nice to see both of you again, and it was really nice to talk to our guests and learn from our guests. And we hope that our listeners also enjoyed the episode, and that you listen into the future episodes as well that we are producing, and we're very excited to have you listen to what we do.
Thank you for tuning in today and learning with us from our guests. If you want more information about what our guests talked about today, check our show notes for links and information in our archive. And don't forget to like and share our podcast with your friends.
If you enjoy our podcast, please consider supporting us financially by becoming a Patreon. For as little as $1 per month, you can support us and get the exclusive benefit of submitting your questions for our interviewees before the interview.
The Sargassum Podcast is produced by Marine Conservation Without Borders and is made possible with financial support and consideration from the Kimberly Green Latin America and Caribbean Center, U.S. Department of Education Title VI grant. It is produced by Jose Martinez, Alex Danieli, Cleo Maridakis, Francisca Elmer, and Alois Lopez, and is hosted by Robbie Thigpen, Francisca Elmer, Jenna Cantuccio, Florence Menez, Cleo Maridakis, and Paula Diaz.
We will be back in 2 weeks with another exciting guest. The music for this podcast is from the song Them I Pray by Drizzle, the Round Drama, an artist from Rotterdam. Follow him on Spotify and YouTube for more music. But for now, this is the full song Them I Pray.